Hi, I'm Michael, and I will be discussing the real projective plane. So this is on the first slide. This is an image of the real projective plane. So the real projective plane is a non-orientable two-dimensional manifold that has a one-sided surface. So what a manifold is on the next slide. It shows here which it intersects and looks very weird, just like the real projective plane. So a manifold is a topological space that resembles the Euclidean space near each point and could only connect to itself with its inverse function, which explains why it goes in itself, but which looks weird to the human eye because we're obviously not used to seeing shapes like this. So a real projective plane is a manifold, basically. But the real projective plane cannot be embedded in a three-dimensional space because it would intersect with itself, like you see here. So basically what that means is in our world, the real projective plane cannot exist because it would intersect with itself and it just wouldn't work. An example is on the slide after manifold in topology. The Mobius strip, the bottom edge of it, if you would glue that to itself, it would create a real projective plane. But once again, it wouldn't work in our world because it would intersect with itself. And it just wouldn't make sense. But the real projective plane can exist in a four-dimensional space, where it would not intersect with itself. But four-dimensional space obviously is not what we live in, and we can't see that, so we won't know, but mathematically it does fit in a four-dimensional space. I mentioned Euclidean space before, which is what this is based on, and Euclidean space was introduced by ancient Greeks, and was created by Euclid of Alexandria, which on the next slide you can see what he looks like. So the Euclidean space is used to distinguish dimensions from other spaces that were later used to discover physics and modern mathematics. So on the next slide, you see what Euclidean space is, which looks weird to our eye because it looks like shapes in shapes, which basically what it is. That's why it's not three-dimensional. And Euclidean space was also used to help have a model of the physical universe and help prove space theorems using mathematics. So it was in this Euclidean space was very important because theorems and other things were used to make it. This was used to make other theorems and mathematical things, but basically, overall, the real projective plane is a four-dimensional object and shape and cannot exist in our world, you could say.